Hello friends, welcome to the online education. Paper number 502, Organic Chemistry and Spectroscopy. We have started a unit number 2 and chapter number 2, Synthesis of Drugs, Dyes and Pigments. We have completed 3 drugs, ibuprofen, atenolol and epinephrine catecholamine or adrenaline. Synthesis of and uses of dyes. Now we have started our second point, dyes. Synthesis and uses of the orange 2. Now we have first take the benzene sulfonic acid or sulfonilic acid. This is the SO3H group. So this is called benzene sulfonic acid or sulfonilic acid. Now we have nitration process with the concentration of H2SO4 and concentration of HNO3. And we have prepared or produced to the 4-nitrobenzene sulfonic acid. This is the structure of 4-nitrobenzene sulfonic acid. This is the 4-nitrobenzene sulfonic acid. It is our first intermediate product. Now we have reduction with the stannous or HCl hydrochloric acid and to produce a 4-amino benzene sulfonic acid. Benzene sulfonic acid 4-amino. Nitro group is converted to the amino group and it is called 4-amino benzene sulfonic acid. So 4-amino benzene sulfonic acid is a second intermediate product. And now we have diazotization process or Sandmeyer reaction with a sodium nitrite plus HCl hydrochloric acid in the presence 0 to 5 degrees Celsius temperature range and to produce a 4-sulfobenzene diazonium chloride. This is the salt 4-sulfobenzene diazonium chloride. N double bond N to Cl and SO3 gas group. So this is called 4-sulfobenzene diazonium chloride. This is our third intermediate product. This is the third intermediate product. Now this third intermediate product 4-sulfobenzene diazonium chloride is reacted with the beta-naphthol. Beta-naphthol. This is the structure of a beta-naphthol. This process is called a coupling process and addition of a beta-naphthol in a 4-sulfobenzene diazonium chloride to produce a orange 2 dye. This is our final product, orange 2 dye, SO3H, and this is our beta-naphthol and to produce a orange 2 dye. So this is the synthesis of orange 2. This is the process of orange 2. Orange 2 dye, it is a monoazo acid dye. What is the monoazo acid dye? Monoazo acid dye means one acidic group combined with the structure is called monoazo acid dye. This is the 1SO3H group, so called monoazo acid dye. 2 acidic group combined, diazo acid dye, and 3 acidic group combined, so it is called triazo acidic dye. But here 1 acidic group combined with the structure, so called orange 2 dye is a monoazo acid dye. Now uses of the orange 2, it is a uses for the dyeing wool, silk, cotton, leather and paper. This is the uses of the orange 2 dye and this is the procedure and synthesis of the orange 2. Now we have learned about our second dye, chrysodine G, synthesis and uses of chrysodine G. Now we have first take the benzene and benzene nitration with the concentration HNO3 and concentration H2SO4 and we have produced to the nitrobenzene. This is the nitrobenzene. This is our first intermediate product. Now Nitrobenzene reduction with the stannous or HCl, hydrochloric acid with a stannous metal, and we have produced to the second intermediate product aniline. This is the structure of aniline. And aniline is reacted with the sodium nitrate. This is the sodium nitrite. In the presence of a sodium nitrite and HCl. This process is called diazotization or Sand-Meyer reaction. Temperature runs 0 to 5 degrees Celsius temperature, means this is the cooling condition. And to produce a benzene diazonium chloride. Benzene with N double bond NCl, it is called benzene diazonium chloride. This is the salt. And now our benzene diazonium chloride, it is a third intermediate product and it is a coupling with a metaphenylene diamine. This is the reagent, this is the coupling reagent and reacted with the benzene diazonium chloride and to produce our final product chrysodine G. So let us see this structure is combined with the metaphenylene diamine combined and to produce a chrysodine G. This is our final product. So guys, this is our two dyes, orange 2 and chrysodine G. Now uses of the chrysodine G. Chrysodine G, it is used for dyeing wool, silk, cotton, leather and also paper. So this is the uses of a chrysodine G, and we have learned about the two dyes, synthesis and uses of orange 2 and synthesis and uses of the chrysodine G. Now we have learned about the synthesis and uses of oramine O. This is our third dye product, synthesis and uses of oramine O. Oramine O is synthesized by two different methods, method 1 and this is method 2. Now we have learned about the method 1. First we take it aniline. This is the structure of aniline. Alkylation with the methyl iodide, 2 mole of methyl iodide and removed 2 mole of hydroiodic acid and to produce a first intermediate product NN dimethyl aniline. 2 methyl group is combined with the aniline and to produce a NN dimethyl aniline. Now NN dimethyl aniline is reacted with the carbonyl chloride. This is the structure of carbonyl chloride, Cl, C double bond O, Cl, and to produce a Missler's ketone. This structure is a Missler's ketone. See the structure of NN dimethyl aniline, NN dimethyl aniline and carbonyl chloride. This carbonyl group is combined with the NN dimethyl aniline and second part of the carbonyl chloride was removed and to produce a Missler's ketone, C double bond O and other phenyl ring, other NN dimethyl to the phenyl ring is combined with this part and to produce a Missler's ketone. So this is the structure of a Missler's ketone. Now this Missler's ketone is reacted with ammonium chloride. This is the ammonium chloride. And this is the ZnCl2 means zinc chloride. And remove the 2 mole of HCl and to produce a oramine base. This is the structure of oramine base. Let us the structure and carbon double bond NH. This oxygen was removed and combined a amine group and also have 2 methyl group with this phenyl ring and produce our third intermediate product. This is the oramine base. Now This oramine base is reacted with HCl, hydrochloric acid, and to produce a oramine O. This is our final product. This is our dye, oramine O. Let us see the structure. This bond have break and one hydrogen molecule is addition and amine group is combined with this ring, and this bond is converted to this bond and forming a double bond, and our other part of phenyl ring is NCH3 twice fluoride. This is the salt, and other part is a N nitrogen with 2 methyl groups, and to produce our final product oramine O. This is the synthesis of the oramine O. Oramine O is also dye product. This is the method 1. Now learn about the method number 2. Now let us take the para-paradase tetramethyl diamino diphenyl methane. This is the structure of para-paradase tetramethyl diamino diphenyl methane. Para-paradase tetramethyl, 2 methyl here, 2 methyl here, so tetramethyl diamino, nitrogen group, that amino group, diamino diphenyl, 2 phenyl ring, diphenyl and also methane. So this structure is called para-paradase tetramethyl diamino diphenyl methane. Is reacted with the 2 sulfur molecule. This process is oxidation process and remove the H2S gas and form this intermediate product. This is the intermediate product. So here bond was break and carbon double bond to sulfur combined is a sulfur with carbon double bond, and 2 mole of tetramole of methyl is combined and form the intermediate product. Now it is reacted with ammonium chloride and zinc chloride in the presence of ammonia. This is the ammonia, and to produce a oramine base. This is similar to the first method, oramine base, that is oramine base. Now similarly to the oramine base, addition to the hydrochloric acid and to produce a oramine O. This is the structure of oramine O. So 2 method, but something different in method 1 and method 2. But this is the synthesis of the oramine O. Now uses of the oramine O. It is dyeing for a wool, silk, cotton, leather and also paper industry.